Hi friends, this is Aishwarya from freshersworld.com. Welcome to our YouTube channel on jobs and careers. The topic that we are going to delve today is permutation basics. So before going in depth of the various formulas that we go into permutation, first let us know what is permutation. So permutation means number of ways a group of things can be arranged. This is a theoretical way of knowing permutation. Let's understand it better. Let's take an example. Let the word letters be A, B, C. How many ways A, B, C can be arranged? So one way to arrange is A, B, C again. Another is A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. So there are 6 ways of arranging these 3 letters. So if it's a 3-letter word or a 2-letter word, let's say even 4-letter word, it is very easy to arrange it in this way. Let's take if it's a 10-letter word, then it will be very difficult, right? That's why we have the formula for permutation, which is nothing but NPR is equal to n factorial by n minus r factorial. Let's understand it better with a couple of examples. So the example 1 that we are going to consider is, let's take 4 letters A, B, C, D. So they are asking you to arrange these 4 letters in 3 spaces. Number of letters that we have is 4 and number of spaces that we have is 3. So we have to arrange these 4 letters in these 3 spaces. So what is the formula of permutation? NPR. So number of letters is 4. And we have to arrange it in 3 places. So 4 factorial by 4 minus 3 factorial, which is equal to 4 factorial by 1 factorial, which is nothing but 4 factorial. Let's understand it with another example. Let's take we have 7 letters now. A, B, C, D, E, F and G. So they are asking you to arrange these 7 letters in 4 spaces. So as we know, the formula NPR is equal to n factorial by n minus r factorial. So the number of letters is 7 divided by what is the spaces is 4. So 7 minus 4 is 3 factorial. So if you simplify this, you will get the answer for this. So the main important thing in the permutation is that you have to know all the factorials from 1 factorial to 7 factorial. 1 factorial is, we know that it's 1, 2 factorial is 2, 3 factorial is nothing but 3 into 2, which is 6, 4 factorial is nothing but 4 into 3 into 2, which is nothing but 24. 5 factorial is 5 into 4 into 3 into 2 into 1, which is nothing but 120. 6 factorial is 6 into 5 into 4 into 3 into 2 into 1, which is equal to 720. And 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1, equal to 5040. Friends, why do we need to know from 1 factorial to 7 factorial here? Because if you see in most of the sums, it will have the combination of these 7 factorials only, predominantly. So if you know these numbers in thorough, you don't have to multiply it every time like 7 into 6 into 5 or whatever. So always remember, along with the formula, always by heart from 1 to 7 factorial, which will be easy for you. Now let us go into the 2 types of various sums that you will face in the permutation. So there are 2 types of sum in permutation. One where we deal with numbers, another one we deal with words. In case of numbers, we have 2 types, which is dealing with 0 included in the question and non-zero, where 0 is not as a part of the question. So in case of words, we have 6 types. First is repeated letters, non-repeated letters. Next is repetition allowed and repetition not allowed. Then it means always together. Here always together means there are 3 types of sum we'll be looking here. One is vowels, consonants and group of words. Similarly, for never together, we will similarly use the vowels, consonants and words. Odd and even places and no two together. You can see here I have mentioned it as no two together. While we are dealing with the sums, I will clearly explain you what I mean by no two together. So once you are thorough with all these types of sum, these are the maximum types of sum that can actually come from permutation. So in the upcoming videos, we'll be dealing each and every topic individually so that we'll have a better understanding of the topic. Hi friends, this is Aishwarya from freshersworld.com. Welcome to our YouTube channel on jobs and careers. In continuation with our permutation basics, now we are dealing with the topic permutation numbers. So as I've told earlier, there are two types of concept you will see in the permutation numbers. First, we are dealing with the non-zero type. So let's go into the question. The question that we are going to deal is how many ways a 3-digit numbers can be formed using 1, 2, 3, 4. So they have given 4 numbers to us in the question and they are asking us to form a 3-digit number. So we know the formula is NPR. So 4 digits they have given and they are asking us to form a 3-digit number. So 4P3. So 4 factorial divided by 4 minus 3 factorial. So once you solve this, you will get the answer for the number of ways a 3-digit number can be formed using 1, 2, 3, 4, which is nothing but 4 factorial. We know 4 factorial is nothing but 4 into 3 into 2 into 1, which is nothing but 24. So 24 ways a 3-digit numbers can be formed using 1, 2, 3, 4. Let's take another example. So similar example is how many ways a 2-digit numbers can be formed using 5, 6 and 7. So what is the formula? NPR. So what is the number of digits given? 3 digits are given. So out of which how many numbers you have to form? 2-digit numbers you have to form. So 3P2. So 3 factorial by 3 minus 2 factorial, which is equal to 3 factorial, which is 3 into 2, 6. The next type of sum that we are going to see is that what we have if we have a repeated numbers. Let's consider this example. How many ways a 2-digit number can be formed using 1, 2, 2, 3, 4. So the formula is NPR and we will write N as 5 here because 5 numbers are given. How many digits we have to form? It is 2. Here we have a catch. Generally we put it as 5P2 and then start solving it. The catch here is 2 is repeated twice. So hence what we do here is divided by 2 factorial. This is the catch here. When you have a repeated numbers, how many times a repeated numbers has come, you have to divide the same number in the denominator. So now solve this. So 5 factorial by 3 factorial divided by 2 factorial. So once you solve the sum, you will know the ways in which a 2-digit numbers can be formed using these 5 numbers. So in this question, they are asking how many ways a 3-digit number can be formed using 7, 8, 9, 9, 4. So okay, they are asking us to form a 3-digit number. They have given you 5 numbers. So as usual, we write it as 5P3. The catch here is 9 is repeated twice. So what do? Divided by 2 factorial. Solve this. 5 factorial by 5 minus 3 factorial divided by 2 factorial. So nothing but 5 factorial by 2 factorial divided by 2 factorial. So once you solve this, we will know the ways in which a 3-digit number can be formed using the given numbers. Next, we will deal with the sums where it has 0 in the questions. So the next type of sum we see in numbers is with 0 in the question. So let's take an example. How many ways a 4-digit number can be formed using 0, 1, 2, 3. So what are the numbers they have given? 0, 1, 2, 3. How many digits now we have to form? 4-digit numbers. So first let's consider 3. So if we have 3 in the first place, what are the other ways in which other numbers can be used here? So it is 3 factorial ways. So which is nothing but 3 into 2, 6. So if we have 3 as the first digit, then there are 6 ways you can form the 4-digit number. Next, let's consider 2. The remaining 3 places are there. What are the ways in which other 3 numbers can be used there? 3 factorial ways, which is 3 into 2, 6. Now let's consider 1. Similarly, for 1, it can be formed by 3 factorial ways, which is 3 into 2, 6. Now, we are coming to 0. If we are going to consider 0 here and fill other numbers here, then you are totally wrong. Because if you put 0 here, it becomes a 3-digit number and not a 4-digit number. Then this whole possibility is totally not possible. Then the number of ways a 4-digit number can be formed using 0, 1, 2, 3 is nothing but 6 plus 6 plus 6, which is nothing but 18 ways. Let's understand it much better with another example. So the next example is how many ways a 3-digit number can be formed using 890. So what are the numbers they have given? 890. So once they give the question, always write the numbers given here and the number of digit numbers they are asking us to form. So it's a 3-digit number. So 3 places we have. So let's start with 8. So if I keep 8 here, there are 2 places. How many ways the other 2 numbers can be formed? 2 factorial ways, which is equal to 2. Let's take 9 here. So 9 in the first place. We have other 2 places. How many ways 8 and 0 can be arranged? 2 factorial ways, which is 2. Now if you're going to take 0 in the first place, then it becomes a 2-digit number. But what are they asking in the question? They are asking a 3-digit number. So this possibility is not possible. So the number of ways a 3-digit numbers can be formed here is 2 plus 2, which is equal to 4. So there are 4 ways in which 3-digit numbers can be formed using 890. So these are the 2 types of sum that you face in numbers with respect to the permutation. One is with 0, another is without 0. If you are thorough with this concept with respect to numbers, it is very easy to crack any type of problem with respect to the similar type of sums. Hi friends, this is Aishwarya from freshersworld.com. Welcome to our YouTube channel on Jobs and Careers. Today, the topic that we are going to deal with is the non-repeated and the repeated letters of the permutation topic. Earlier, we discussed on the basic permutation topic and as well as the number types of problem that we deal in the permutation. Now, we are going to the another types of problem in permutation, which is nothing but dealing with the words. So, the first type in that is the repeated letters and the non-repeated letters. Let's get started. So, the first type is non-repeated letters. So, let's deal with some examples to understand the concept better. So, the question is number of ways a word can be arranged. So, they have given the word shirt. So, how many letters are there? 1, 2, 3, 4, 5. So, 5 letters are there. So, if you have watched our basics video, in that we have dealt with an example as ABC. The number of ways ABC can be arranged is 6 ways. Let me go through it again. Example, let's say ABC. How many ways it can be arranged? Nothing but ABC, ACB, BAC, BCA, CBA, CAB, which is nothing but 6. What is 6? It is nothing but 3 factorial ways a word can be arranged. So, when you ask a question, how many ways a word can be arranged, it is nothing but number of letters in the word and then the factorial. So, what will be the answer for it? So, we have 5 letters here, then the answer is 5 factorial. So, as now if you are aware of what is the value of 5 factorial, we know that it is 120. Every time doing all these multiplication is difficult. So, always remember to memorize from 1 factorial to 7 factorial. So, let's take then another example. So, they have given how many ways a word can be arranged. Pen. So, there are 3 letters here. So, as per our formula, number of letters is 3. 3 factorial ways, which is nothing but 6. Let's take another example. So, they have given a word called pant. How many letters are there? 4 letters are there. So, what is the answer for this? It's 4 factorial. 4 factorial is nothing but 24. Let's take another example. So, they have given 6 letters here. So, what is the formula? Number of letters and the factorial, which is 6 factorial, which is nothing but 720. So, this is the way a non-repeated letters can be arranged. The next type of sum we're going to see is with the repeated letters. So, in the last concept we dealt with non-repeated letters. Now we are going to deal with repeated letters. So what we did in the non-repeated letters, we took the number of letters in the word and the factorial of it. So similar thing we are going to do with a minor change. Let's take an example. So the word they have given is laptop. They are asking us how many ways the word can be arranged. So what is the number of letters? So we have 6. So what do? 6 factorial divided by. Why we are doing divided by? As we have seen in the numbers video, the number of repeated letters has to be put in the denominator. So what is repeated here? So P is repeated here twice. So 2 factorial. So remember it this way. Number of letters factorial, which is the same for non-repeated letter, divided by number of repeated letters factorial. Always remember this. So once you solve it, you will get the answer in which number of ways the word laptop can be arranged. Let's take another example. So we have the word aptitude. 1, 2, 3, 4, 5, 6, 7, 8. So number of letters is 8 factorial. What is repeated here? We have T repeated here twice. So as per the formula, number of letters is 8 factorial. Number of repeated letters T is repeated twice. So 2 factorial. Let's take a bit tough example so to understand the concept much better. So the word they have given is Mississippi. So let's count the number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So as per the formula, we take the number of letters as 11 factorial divided by what are the number of repeated letters. So what is repeated here? So I is repeated 4 times, S is also repeated 4 times, and P is repeated twice. So I is repeated 4 times into S is repeated 4 times into P is repeated 2 times. So once you solve this, you will get the answer for number of ways the word Mississippi can be arranged. So now we have dealt with the ways in which repeated letters and non-repeated letters can be arranged. Now we are going to go to the next concept of repetition is allowed and repetition is not allowed. So the next concept is repetition is allowed and repetition is not allowed. So first let's understand the difference between repetition is allowed and repetition is not allowed. Let's take for example, they are giving us the word AB and asking us how many ways it can be arranged. If the repetition is not allowed, then what do? AB, BA, which is nothing but 2 factorial ways we can arrange it. What if the condition is repetition is allowed? So what do you mean by repetition is allowed? So there are 2 letters. Repetition is allowed means A can be repeated twice. So AB can be written as AA, AB, BA, BB. So if you see that in case of repetition is allowed, we can see that A itself can be repeated twice and B itself can be repeated twice. So here we can say it is being arranged by 4 ways, which is nothing but number of letters that we have part 2. So this is the number of letters and number of repetition we have. So nothing but 2 part 2. So this is the difference between the repetition not allowed and repetition is allowed. Let's take few examples. So let's take the word shirt. So how many words we have? We know in case of repetition not allowed, we can easily tell it as 5 factorial. In case of repetition allowed, what we dealt here? 2 power 2. So number of words on top of the power also the number of letters that is used. Let's say it's 5 words, then 5 power 5. So this is the answer that comes for repetition allowed. Let's take another example. Let's take if it is pant. So pant has 4 words. When case of repetition not allowed, we can easily write it as 4 factorial ways it can be arranged. In case of repetition allowed, we will do it as 4 power 4. Now we don't have a repeated letters in case of shirt and pant. Now let's take a repeated letter as an example. So in case of aptitude, you can see T is repeated twice. So what do we do generally in case of repetition not allowed? We will first count the letters 1, 2, 3, 4, 5, 6, 7, 8 divided by the number of repeated letters. We are going to do the same thing here. So as usual what we did earlier, the number of letters power of the same number of letters. Same here. So how many words are here? 1, 2, 3, 4, 5, 6, 7, 8. 8 power 8 divided by what is repeated here? T is repeated twice. So 2 factorial. So this is the way in which repetition allowed and repetition not allowed type of sums comes here. So in this video, we dealt about two types of permutation problem. One is repeated letters and not repeated letters. So another type of sum is the repetition allowed and repetition not allowed. Today, the type of problem that we are going to deal with is permutation always together. In last videos, we discussed on the two types of problem. One is with numbers, another is with repeated letters and non-repeated letters, and repetition allowed and not allowed. Today, we are going to deal with always together type of problem. In always together problems, we have three types. One is vowels always together, consonants together, and other words together. First, let's start with vowels always together. The question is, how many words can be formed when vowels are always together? So let's take an example. So the word is learn. So what are the vowels here? E and A. So they are saying E and A should always be together. What are the remaining letters? L, R, N. So they are saying EA will always be together. They are not saying where it should be. So what are the various places in which it can be arranged? Either it can be arranged in the front, so it becomes like EA, L, R, N, or in between L and R, or between R and N, or in after N. So there are 4 spaces. So which is nothing but 4 factorial. And what is probability between these two? Which is nothing but EA or AE. So in 2 factorial ways it can be arranged. So how many words can be formed using the word learn is nothing but 4 factorial into 2 factorial. Let's take another example with the repeated letters. So in case of aptitude, what are the vowels here? A we have I, U and E. So vowels are always together, so write it separately. What are the remaining letters? So we have P, we have T, we have T and D. So what are the places that it can be arranged together? It can be in the front, between these, between here, or in the last. So there are 5 spaces. So 5 factorial ways. In this you can see T is repeated twice. As we have done in the previous videos, we have to divide it by 2 factorial into. What are the vowels given here? 4 vowels are there. How many ways these can be arranged within themselves? Is 4 factorial. So once you solve this, you will know how many ways the word aptitude can be arranged when the vowels are always together. So in the previous concept, we dealt about vowels always together. Similar concept is applied for consonants always together. Let's take an example. How many words can be formed when consonants are always together? So what we did in the earlier types, we always clubbed together the vowels. Now we have to do the opposite of it. Now we have to club the consonants together. So what are the consonants here? L, G and L. L, G, L together. So remaining letters is nothing but E and A. What are the various places L, G, L can be arranged? These are the 3 places it can be arranged. So it is 3 factorial ways. And within this, how many ways it can be arranged? It's 3 factorial. And L is repeated twice, so divided by 2 factorial. So once you solve this, you will know how many words can be formed using the word legal. Let's take another example. Let's take the word learn. So what do we do here? We will club the consonants together. L, R, N. Remaining letters that we have is E and A. What are the places in which L, R, N can be placed? Either here, here, here. So we have 3 places, so we write it as 3 factorial. And how many ways L, R, N can be arranged? In 3 factorial ways. So if you can see that similar type of problem can become for other words. So what do you mean by other words? So they will give you a question like let's take learn, and they are giving in the question that R and N should always be together, or they will give L and E should always be together. So whenever that always together comes, club those words and put it in the bracket. Remaining letters you can write it separately and fill the spaces. So that's how you have to do for always together. So now we have dealt with 3 types of sum in always together, which is with vowels, consonants and other words. Next topic that we are going to deal with, never together, with the similar vowels, consonant and other words. So this concept is nothing but never together. In the previous concept, we dealt with always together with respect to vowels, consonants and other words. So similarly, we are going to 3 types and we are going to take the concept of never together. So what is the formula here for never together? It is nothing but total number of ways minus always together. Let's take an example to understand the concept better. Let's take the word learn. So what is the total number of ways the word learn can be arranged? total number of ways, it's nothing but 5 factorial. So we don't have a repeated letter, so nothing will come in the denominator. Next, always together. How did we do the sum always together? So what we did, vowels are always together, so E and A will be together, remaining is L, R, N. What are the spaces here? 4 spaces we have. So we did as 4 factorial into 2 factorial. Now the question is not always together. They are asking about what happens when the vowels are never together. So vowels are never together is nothing but total number of ways minus always together. So which is nothing but 5 factorial minus 4 factorial into 2 factorial. So once you solve this, you will know the answer for word learn when the vowels are never together. Let's take another example with a repeated word. So the word sister. So as usual, for total number of ways, is nothing but how many words we have? We have 6 factorial way. And what are the repeated letters? S is repeated twice, so divided by 2 factorial. Now we are going to take vowels are always together. So I and E are together. Remaining thing you have is S, S, T, R. What are the spaces here? So we have 5 spaces, which is nothing but 5 factorial into 2 factorial. What do we miss here? S is repeated twice, so divided by 2 factorial comes. So what is the question? They are asking never together. So the answer is for never together is total number of ways, which is nothing but 6 factorial by 2 factorial minus vowels always together, which is nothing but, you can cancel this, which is nothing but 5 factorial. So this is another concept. So similar type of sum will come with consonants or other words. Let's take an example. Let's take the same word learn. So now the concept is consonants are never together. So the example is learn. So the consonants are not together. So first we're going to take the total number of ways, which is nothing but as usual 5 factorial. Now always together, which is nothing but LRN together. EA will write it here. What are the places we have? 3 factorial. LRN can be arranged in 3 factorial ways. So the consonants never together for the word learn is nothing but 5 factorial minus 3 factorial into 3 factorial. So once you solve this, you will get the answer for the word learn. In case of the concept of other words, they will ask you the question like R and R can never be together or L and R can never be together. In that case, you do the similar way how you did it for vowel and consonants. What do? Total number of ways the word can be arranged is nothing but the number of letters in that, and always together you have to find where you have to club the words that they have given and the remaining spaces. So you will find the always together, then subtract both of them will give you the never together. So in today's video, we dealt about 2 concepts, which is always together and never together. Today, we are going to deal with a type of permutation sum, which is nothing but odd and even places. In our previous videos, we dealt with different types of permutation sums that you can face in an aptitude exam. This is a continuation to it. So let's get started. So the question is, how many ways word fridge can be arranged in such a way that vowels occupy only odd position? So they are given the word fridge. So how many places are there? So we do have 6 places. Just number them for your own information. So they are telling that vowels occupy only odd position. What are the vowels here? So we have the word I and E. So we have 2 words. So they are saying that they occupy the odd positions. What are the odd positions here? 1, 3 and 5. So we have 3 positions out of which 2 vowels have to be arranged. Just nothing but 3P2. What are the remaining letters that we have? We have F, R, D and G. These can be arranged in 4 factorial ways. So which can be simplified as 3 factorial by 1 factorial into 4 factorial, which is nothing but 3 factorial into 4 factorial. So once you solve this, you will know how many ways the word fridge can be arranged when the vowels occupy only the odd position. Let's take another example for the even position. So the question that they have given is, how many ways word aptitude can be arranged in such a way that vowels occupy only even position. So what they have given, the word aptitude. Just write it for your own information and write the number of places. So we do have 8 places. 1, 2, 3, 4, 5, 6, 7, 8. So what do they say? Vowels occupy only even position. What are the vowels that we have? A, I, U and E. So we have 4 vowels here and they are saying they are occupy even position. So 2, 4, 6 and 8. How many places we have? We have 4 places, out of which 4 vowels has to be arranged. What are the remaining letters that we have? So we have P, T, T and D. So these are the remaining letters. So this can be arranged, as we know, in 4 factorial ways. But there is a catch here. You can see T is repeated twice. So what do? Divided by 2 factorial. So 4P4, if you do this, which is nothing but 1 into 4 factorial by 2 factorial. So once you solve this, you will know the number of ways word aptitude can be arranged when the vowels occupy only even position. Similar type of problem will come instead of replacing vowels with consonants and other words. So if consonants is there, instead of clubbing the vowels, you will be clubbing the consonants together and do the similar way in which you have done it for vowels. So this is the concept for odd and even places. The next concept that we are going to deal with is no 2 vowels or consonants together. So the next concept that we are going to deal with is no 2 together. So in case of no 2 together, like the previous concept, we are going to deal with vowels, consonants and other words. So in case of no 2 together, there is a difference between no 2 together and never together. I will deal you with an example. Let's take the example is how many ways the word fridge can be arranged such that no 2 vowels are together. So understand the question, they are given no 2 vowels are together. In case of never together, these can never be together. In no 2 vowels, let's take for example, so I and E are taken it separately. The remaining letters are F, R, D and G. So they are saying that I, E can be either I be here or E be here. So if I is here, E can be in some other place. They cannot be together in a single place. So how do we do this? Similarly, let's club the vowels together. What are the remaining letters? We have F, R, D, G. What are the places that we have? So we have 1, 2, 3, 4, 5. 5 places we have, out of which 2 can be arranged in different places. So we take it as 5P2 into, what are the remaining letters? We have 4 factorial. In case of never together, what do? We take the total number of ways, subtract it from always together. In case of no 2 vowels, what do? We do the same method as such as always together. As we club the vowels together, then we find the number of places. The only change here is there are 5 places in which I and E has to be arranged. So the change here is in this. Into, as usual, the remaining consonants. It can be arranged in 4 factorial ways. Let's deal with another example to understand this concept. So they are saying how many ways the word places can be arranged when the vowels 2 vowels are not together. So what are the vowels here? A and E. So write it separately. What are the remaining letters? We have P, L, C and S. What are the various spaces we have? So we have 5 spaces, out of which 2 vowels has to be arranged. 5P2 into, what are the remaining letters that we have? 4 factorial. So once you solve this, you will know how many ways places can be arranged when no 2 vowels are together. Similar type of problem can come with consonants and other words together. In case of other words, as I have told earlier, they can ask that, let's say P and S can never be together, or L and A are not together. So if they're going to ask like this, you're going to do the same method as you've dealt for vowels not together. So in case of permutation, we dealt with 2 concepts, which is with numbers and words. In case of numbers, we dealt with 0 and without 0. In case of words, we dealt with repeated letters and non-repeated letters, and then repetition allowed and repetition not allowed, always together, never together, odd and even places, and no 2 vowels or any words together. So these are the various types of problems that you can deal in permutation. If you are thorough with these basic concepts, any type of sums that you're going to face in an aptitude exam will be like a cakewalk. So if you're a person who's looking for a job, Please kindly register to our freshersworld.com. Kindly like this video and subscribe to our channel. Thank you.